Hello, today I'll be discussing CS50 2025 problem set 4 filter, and in it I'm specifically discussing the blur part of it. So here I've taken a 4 by 5 image. This is the height and this is its width horizontally, and J goes from 0 to 1 to 2 to 3, and height goes from 0 to 1 to 2 to 3 to 4. So this is a nested for loop, as we have seen in the course before. The I is initialized at 0 and goes up till the height, and J moves up until the width right here. So what I have actually done here is that I have initialized the some green, some blue, and some red, and the pixel count to 0. Why have I done this? I'll explain later. Uh, the blur algorithm actually works by calculating the average of all the pixels that surround the particular pixel, including and I'll take into average of this pixel also. So the average will be calculated of all the RGB channels for these 9 pixels. Similarly, for a vertex pixel, the average will be calculated by the average of the 4 of its neighboring pixels for this pixel right here. For an edge pixel, we will take the average of 6 values over here. Now, average of 6 values of the 6 RGB channels of the images. Now, what I have done is this is the DI, which moves from -1 till and to 1. Similarly, DJ in it moves from -1 to and to 1, and it increments by a 1 through each turn. Now, DI and DJ are actually the moves we want to give to the algorithm to check its neighbors. Say I have this here, this pixel right here. This will be represented by image I is 1 and J is 1 dot RGBT, red, blue, and green. Red, blue, and green, and we will actually take the average of these in our algorithm. Now I have highlighted this pixel. So the DI is the actually change in its movement in the x direction, and DJ is its change in the y direction. DI moves from -1 to 1, and and this is the final movement of the, say, a kind of arrow that points to a pixel. So the DI can be -1, so this the capital I can be 0 comma 0, sorry, can be 0 comma 0, can be 0 comma 0, because one time will come when DI is equals to -1 and DJ is also equal to -1. So we will be pointing to this pixel by moving here. Similarly, DI can equal to a 1 in this case. Hence, we will move to I is equal. Actually move to the second column, second row, and we will actually move downwards. And if j remains 0, dj remains 0, we will actually come to this pixel. uh, Now this works good if we were actually in the middle somewhere here. We were not actually at the vertex or at the edge part of this image. Now after that we have some checks that to see if the pixel we have arrived to actually exists or not. Say we are here, and actually we dj and di are both -1. We will actually move into the void here, and this pixel doesn't exist. So we have this if part here with 2 and 4 and logics, sorry, 3 and logics. And if it actually finds the pixel, it will increment the pixel count to 1. It will add it will add 1 to the pixel count. Similarly, the sum green and blue will also be added to the and also the sum ij of that final pixel at which we have arrived will be added to the green, blue, and red part of the variable that we are actually calculating. Now, after this is actually the movement code for a particular pixel that I and j arrive to. This is actually the movement. The movement actually calculates all the pixels. For averaging, we need the pixel count and all the sum green, red, and blue that is actually needed. So after we are done moving around, I I am not directly assigning the values directly to the image RGBT image array. Not It's not actually an array, it is a 2D array or a vector. So I'm not directly assigning there, because then we will actually go around modifying the values, and after we move on to the next value, the previous value will be changed. So the image will obviously become a hodgepodge, and this is not how we do uh the blur algorithm here. So actually made a buffer, the buffer RGB triple buffer identical to the image RGB triple 2D array that was given by CS50. And here, after we're done moving around and we actually calculated how many pixels are there, we actually divide the sum green by pixel count, some blue by pixel count, some red by pixel count, and actually populate the 2D array. And finally, uh, after we are done, this algorithm will take some time to process, and because of how many pixels are there in the image. After that, I'll write it actually a nested for loop, like so. Int j is equals to 0 and j is less than width, j plus plus, and we will actually go on and do image I dot j is equal to buffer I dot I and j. Sorry, this is the inside loop. This is the nested for loop to copy all the values from the buffer to to our image 2D array. So yeah, that's about it. And post note, this is actually wrong. We are not rounding properly here. Why? Because we when this operation is being done, all both of them are already integers. So this part already produces an integer answer, and after that we cast it as a float and then it rounds it. So this is actually useless. The float part is actually useless. What we will have to do is cast one of them as float. Actually, these are not proper numbers. Otherwise, I could have just done put a decimal and did point O, for example, and it will the C would have actually understood that this is a float and would have treated it as a float, and it didn't wouldn't have need to cast it as a float. But here, this is not a proper number. This is a variable, so we actually have to cast like this. My bad. Some green divided by pixel count, and then round this result. This will actually be the correct rounding for the buffer to store it in the buffer. So that's about it. Thank you.